All right, well, welcome to Chapter 11. We're going to be talking a lot about multivariable functions. So far in Chapter 10, we've talked about equations of three or less variables and what they look like, what their graphs look like, and our three equations of three or less variables give rise to surfaces in three space. We're thinking in three space. So today our goal is to study functions of typically two variables, sometimes more, and see how what they mean, how we can interpret them, and so on and so forth. So definition, so a function f of two variables assigns to each ordered pair x, y. There's two variables now, not just x, but x and y. It assigns to each ordered pair in its domain a unique real number denoted f of x, y. And so write functions of one variable, we write f of x, and x is getting mapped to f of x. Functions of two variables, xy is getting mapped to the number f of xy. Let's think briefly about the graphs. So functions of one variable, the graph looks like a curve, right? Functions of one variable, x gets mapped up to f of x, and the set of all of those traces out a curve. What I want you to realize is that functions of two variables actually trace out a surface. So the graph of a function of two variables, the graph not of, is a surface in R3. It's a surface in three space. And so just a quick example, we'll write down f of xy equals x squared plus y squared. And so, for example, I can compute f of 1, 1. X is 1, y is 1. I get out 2. F of 2, 3. I get out what 4 plus 9 is 13. So you can run numbers as much as you like, just like before. Just like before, the output of a function for us is a number, right? We're plugging in something, we get out a number. That's important to keep track of. I want to begin by showing you a not very helpful way to visualize functions of two variables. So one way you can do it is you can pick your favorite point, x comma y, in two space. This is the standard xy plane. And then you can imagine mapping it over to another real number line, and you get a point, and we'll call this f of xy. And this is what is happening. Even though we don't like to visualize it this way, this is actually happening. Maybe here's 0, and we're heading towards positive infinity out here and minus infinity out here, whatever. So this is really not a super helpful way to visualize functions of two variables most of the time. Sometimes it might be. What we typically do is we make an identification. So we typically identify the point x comma y with the point x comma y comma 0 in R3. And that's what I need you to see. Functions of two variables, you are plugging in something in the xy plane. All right. This is a point in three space, but really it's living in the xy plane in three space. And so here's how we're going to think about it. This point is the point x, y, 0, but we're typically going to identify this as our original xy. So I'm going to talk about points in the xy plane as just x comma y. Don't think I've lost my mind. I just don't always write the 0. It's understood. If I put it in the xy plane like this, then you know the z coordinate is 0. So this xy 0, which I'm going to often just write as xy, is getting mapped up to the point x comma y comma f of xy, and that helps us see what z is. Right here, z is playing the role of, f of xy is playing the role of z. So before, when you were doing a function of one variable, you would say y was f of x, right? Because it is. And now z is f of xy. And so sometimes, let me just point this out to you, sometimes we're just going to identify this as just f of xy. So here, I'll do it over here. You might have a similar picture where we do something like this. Here's my xy, and then I might map it up and say, hey, that's getting mapped to the number f of xy. All of this is what's called abusive notation. The correct notation I've written here, right? That's what's really happening. You're sending the point xy 0 to the point xy f of xy. But we'll sometimes write it like this as well. Okay, so let's go back to our example. So we started with this function f of xy is x squared plus y squared, and now that we realize that f of xy, we should think about that as z. This is the same as z equals, or not z squared, z equals x squared plus y squared. Well, we should recognize that. That's a paraboloid opening up. We studied that back in 10.6. And so you can sort of see, okay, here's a point in the xy plane getting mapped to that point on the surface, point getting mapped to that point on the surface, so on and so forth. You can sort of see what's happening here. All right, well, let's end this first video here, and in the next video we will talk about domain of functions of two variables and look at some fun examples as well.